بسم الله الرحمن الرحيم. Ventilator waveform analysis. What are the types of inspiratory time and how to synchronize patient ventilator and inspiratory time? In inspiratory time, we have three types of inspiratory time. Ventilator inspiratory time, which is preset by the operator. Patient inspiratory time, which is neural inspiratory time, and this is patient dependent. The last one, or the third, is the predicted inspiratory time. The delivered tidal volume and its inspiratory time, we can call it predicted tidal volume and its predicted inspiratory time, and this depends on the preset inspiratory time as in pressure controlled ventilation, the rising time, the expiratory sensitivity as in pressure support ventilation, and the ventilator driving pressure. In addition to these, the patient driving pressure and the inspiratory time constant, inspiratory resistance, and total compliance. All of these determine the predicted tidal volume and its predicted inspiratory time. The predicted tidal volume and the predicted inspiratory time may be either complete predicted tidal volume and complete inspiratory time for this tidal volume, and this is defined by when the tidal volume ended with zero flow. Look at this. This is the tidal volume and this is a zero flow. Here, this is the tidal volume and this is zero flow, and this is an inspiratory pause. The second one, which is incomplete predicted tidal volume and inspiratory time. The tidal volume does not end with zero flow. This is the inspiratory flow. It does not come to zero. So this is the tidal volume. So this is an incomplete predicted tidal volume with incomplete inspiratory time. This is a case of complete predicted tidal volume and inspiratory time. Look at the tidal volume the flow came to zero, and this here inspiratory pause, which means that the preset ventilator inspiratory time is larger than the predicted inspiratory time. Also, this case is a complete predicted tidal volume and inspiratory time. When you look at this, is the tidal volume and the flow came to zero. But in this case, the preset inspiratory tidal volume of the ventilator matches or the same like the predicted inspiratory time. Not like the other one, the previous one, the preset ventilator inspiratory time was larger than the predicted. That's why we had an inspiratory pause. But here there is no inspiratory pause. This case is an incomplete predicted tidal volume and incomplete predicted inspiratory time. When you look at this is the tidal volume and the flow does not come to zero. So this is an incomplete one, which means that the preset ventilator inspiratory time is less than the predicted inspiratory time. To repeat again, the preset ventilator inspiratory time may be, number one, it is the same as the predicted inspiratory time, come to zero. or the preset ventilator inspiratory time may be more than the predicted inspiratory time to develop an inspiratory pause, or the preset ventilator inspiratory time may be less than the predicted inspiratory time. That's why the flow does not come to zero. How to adjust the ventilator, especially the inspiratory time? The first one, you have to set the ventilator inspiratory time to be the same as the predicted inspiratory time. To match, this is the flow comes to zero. This is the inspiratory time of the preset inspiratory time of the ventilator to match the predicted one. Then adjust the ventilator inspiratory time to the patient. So we are left with the patient. So this is the ventilator with the predicted are the same. We are left with the patient. Look at this. This is the zone number 2. Look at the end of the pressure time curve. If it is smooth like that, this means that there is a match between the ventilator inspiratory time, the patient inspiratory time, and the predicted inspiratory time. But if it is overshooting like that, this is overshooting. This means that what you call late cycling. It means that the patient inspiratory time is shorter than the ventilator. It means that the patient ended and still the ventilator is pushing or is inspiring or is delivering air to the patient. That's why it is overshooting. So how to solve it? Just to decrease the ventilator inspiratory time in order to get this shape. The third one, which is damping. This is what we call early cycling. It means that the patient inspiratory time is larger than the ventilator. The patient is still taking his respiration, but the ventilator ended his cycle. So in this case, you have to increase the ventilator inspiratory time in order to get this shape. So this is the problem of late cycling, early cycling, how to diagnose and how to treat. Thank you.